Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. Today, after almost a year of game engine programming videos, I'm really excited to finally start working on the graphics renderer. So far we have been defining a lot of general architecture for the game engine, and I think that will help us a lot by not getting too distracted during implementation of a big subsystem like the graphics engine. Now that we have an idea of how to structure the data within the engine, things like entities and their components, and making systems that are platform and API agnostic, it will be hopefully easier to take any subsystem and implement it in isolation without having to worry too much about how it will fit in the rest of the engine. I'll start this episode by creating a high-level renderer which exposes an interface to the rest of the engine for graphics rendering. We then can go ahead and plug in a low-level renderer that will use an API of our choice, which in my case is DirectX 12. So today I'll also get us up and ready for developing a DirectX 12 renderer. So let's get started, and I hope you'll enjoy today's video. Okay, let's close all of this and all these files as well. So for a while, I'll not be doing anything with Primal Editor because we are going to develop the graphics engine and the renderer. So we will be mainly working in the engine now. And to test the engine, I'll first add a new test for our renderer in the engine test. So let's go ahead and add a new header. Then, like we did before, for example, this test window, we have to include this test header and the headers that we will be needing for our tests. Now, because these tests are a bit more involved than we have been doing so far, I'll also add a new CPP file that will contain the code for these methods here in this class. Again, because we want to test the renderer, we also need to open some windows to render the graphics. So the code that I'm going to write is pretty similar to what we have here in test window. So for a part, I can just copy paste this to our new test. Now here I'd like to implement those functions from our class. So let's start with initialize. Actually, let's copy this part as well for our window initialization. I already have the code here, so I don't have to type it here again. Now in this case, because we are going to test the renderer, we need render surfaces. If you remember from our window tests here, we have platform windows, but we also defined a new structure in graphics renderer. That is a render surface, and that contains both the window and the graphics surface that we are going to initialize using a graphics API. As you can see here, this is now empty. And when we define this, it will also be API independent. So it doesn't matter what graphics API we'll be using. This surface is just as this window was. independent of what API we will be using, because it's basically just an ID. So now instead of creating just a window, we'll create a render surface. First, we need to add the header file for the renderer here. And again, we are just going to create 4 windows and 4 render surfaces. And the purpose of that is to test if the renderer also can handle more than one render surface. Now we need to change a couple of things here. Instead of window, we have surfaces. And I'll move this part to a separate function that will create both the window and the graphics surface. Okay, so this part is now done, and we need to modify shutdown methods to also work with surfaces instead of windows. And like I did for creating a render surface, I'll move this part to a separate function, and that destroys the window and the graphics surface for us. Now what I would like to do is to make it possible to initialize and shut down the graphics renderer. So what we need here is something that we can call like this. And I would also like to give it a particular API to be initialized. So for example, if we would like to initialize the renderer with DirectX or with Vulkan or OpenGL, then we could specify that here. Something like this. And I would also like to know whether this initialization succeeded or not. So we need to return a Boolean value indicating that. And if that result was false, then we failed to initialize the graphics engine and we need to return. And likewise, when we shut down the test application, we need to shut down the graphics engine as well. Okay, and all I want to do for today is to implement these 2 functions and also the infrastructure that's needed to do so without involving any API-specific types. So therefore, I'm going to write a high-level renderer first, which is basically just a thin wrapper around any low-level renderer that we'll be writing, and it will specify an API-independent interface. So let's implement this function first. And we need an enumeration to specify graphics platform that we want to use. And I can add it here as well. And in the future, if me or someone else wants to add a new low-level renderer, they can just add another constant here in this enumeration. But for now, I'm going to first implement a Direct3D 12 low-level renderer. And that's just because it's more complete, in my opinion, than Vulkan. And it's more used than Vulkan, as far as I know. I could be wrong. And most importantly, I am more comfortable with this API than with Vulkan. Okay, let's add the shutdown function here as well. Now going back to our test, you can already see that we can call these functions like so. Let's update our window procedure to work with the surfaces as well. So when we try to build the project now, you can see that it compiles, but it fails to link because it finds unresolved externals for initialize, run, shutdown, and graphics initialize and graphics shutdown. So the first thing I need to do is to also update main to include our test, because otherwise we get these unresolved externals. Here we'll add one more test. Now the only unresolved externals that we are left with are the initialize and shutdown functions for graphics. Now what this graphics actually does is just forward our calls to the low-level renderer most of the time. So we need to have something that will define an interface for any low-level renderer that we'll be implementing. So I'll add a new header here for the graphics interface. Now, as you might have already guessed, I'm going to use a structure with function pointers and just set these function pointers to the functions that we will be implementing in the low-level renderer. You might as well argue why I'm not using a base class with polymorphism for different graphics API. And my reason for not doing that is the fact that we are going to just have one renderer that's initialized for one particular API. So we don't have multiple renderers that are using different API. And therefore, it doesn't really make sense to have a base class and use polymorphism with virtual functions and those kind of things. But feel free to implement this part or the interaction between the high level and the low level renderer in any way that you feel is the best for you. I think this works best for me, so I'm going to do it like this. Okay, now to get the interface to our low-level renderer, I'll add first a CPP file for the renderer. Here in this anonymous namespace, I'll have an instance of our low-level graphics interface. Now here I am going to write these two functions. Like this, and to write this function I need to have a switch statement that will check for this graphics platform that we want and call the right low-level renderer function to initialize this platform interface. So in the case that we would like to initialize DirectX 12 renderer, we need a function in the namespace d3d12 that will get us the interface to that renderer. Okay, now we are kind of ready to start implementing our low-level renderer. So here I'll add a new folder for each low-level renderer that we are going to use. The first one of which is DirectX 12. And the first file, of course, is the one that will get us the interface. Here I'm forward declaring platform interface, so I don't have to include the header for the renderer here because we are going to write this function in its own CPP file. As you can see here, I need to use this // to go back one level in the structure to be able to access these include files. And I would like to get rid of that, so I could just do this and it would understand where this thing is. And to do that, I'm just going to add a new additional include directory in the properties for engine project. Here in all options, you can see that it already has project common. So we can already access all the headers that are in here automatically, but I'll also like to add for all configurations, just the project directory itself, like this. And now, as you can see, it recognizes this graphics and it has no trouble accessing this header. So now we can move on and write our code here. And this one shouldn't be the renderer, but the interface. So it knows what this structure is. So for the low-level graphics engine, I'll have a core namespace that defines and contains all the core functionality that we need to initialize and shut down the engine, as well as adding surfaces and common bookkeeping of the whole graphics engine. So we need to add a couple of more files that will contain this code. Okay, here we'll have the initialize and shutdown functions for our low-level renderer. And then we can go ahead and implement these in the CPP file. Now here I can go ahead and implement the initialization function. So for this first implementation of initialize, we will take the following steps. So first we need to figure out which adapter, if any, we can use to initialize a Direct3D12 device on. So an adapter is a graphics card to which an output device is connected as well. And an output device is a computer monitor, for example. And then check the supported feature level, because DirectX has feature levels and we need to figure out the highest supported feature levels, so we don't use any features that are not supported. And finally, we need to create a device which is a virtual representation of our graphics card. So this device is something that we want to keep during the lifetime of our graphics renderer. So I'll add a variable that will hold a pointer to this device. Now, as you can see, this device is not recognized because we haven't included anything about DirectX 12 in our project yet. So instead of including the header files for DirectX 12 in our common headers, I'm going to have a specific common headers for the Direct3D 12 renderer that we are implementing here, and include the headers for DirectX 12 in there. Because of course there is no use for them anywhere else in the engine. So let's add a new header file. Here first, I'll include our good old common headers. and also a reference to the high-level renderer for some interfaces that we'll need later. Then come the DirectX specific headers that we need. DXGI stands for DirectX Graphics Infrastructure, which was originally part of DirectX, but Microsoft decided to pull it apart to be used for detecting adapters and enumerating outputs and creating swap chains and basically stuff that don't directly have to do anything with graphics rendering, because that functionality is exposed by the D3D12 header. WRL contains only one thing that I need sometimes, and that's a class that resembles a smart pointer, but then for component object model objects. As you might already know, DirectX 12 is implemented using component object model, and when we get a pointer to a COM interface, it will increase the reference count of it, and we need to call release when we are done with it. And using a smart pointer class that's included in this one will automate that process. I'm not going to use it all the time, but just sometimes for very basic things, because I'd like to be in control of the lifetime of most of the COM interfaces that we'll be using in the DirectX renderer. Next, I need to tell the linker which libraries it should use to link with DirectX 12. Of course, we could also set the input libraries in the project settings, but since we are using these libraries only for the low-level renderer, it would make more sense to have them here. Now we can include this header in core header, so it will be included in our CPP file as well. Now, as you can see here, we have a list of interfaces for Direct3D12 device. Each of these interfaces adds some new functionality to the older interface, and I'm going to use the latest one. That doesn't mean that I'm going to use all of the functionality that is implemented in device 8, but it never hurts to have the latest one as well. Now we have got pretty much everything that we need in order to start using the Direct3D API, and I'd like to continue writing the initialization and shutdown functions in the next video. Thanks for joining me today, and I hope that this video was useful to you, and I hope to see you next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!